Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to Pakistan School Muscati Learning, and we are learning from our book Amazing Science Grade 4, and I am Nisada Atiza. Virtual classroom rules. Find a quiet place free of distractions, TV, parents, toys, pets, siblings, etc. Show up in time for class and wait to be admitted into it if needed. Be respectful at all time when your video is on. No inappropriate language or no hand gestures. Stay on mute. Click the raise hand button if you have a question or something to share. Stay on task and focused so you don't miss anything the speaker says. Our topics today is unit number 11, force and machines. Students, force causes things to move. So here in this chapter, we learn about force. What can force do? What do we mean by speed? Force can change the shapes of objects. Then we'll discuss about one activity of book page number 86. Then discuss about machines, what machines need, and then name of some simple machines and their work in our daily life. So let's get started, students. Force. Student, when we push a trolley, it moves. What makes a trolley move? What keeps an aeroplane in the air? What cracks the shell of a net? Each of examples involves some kind of a movement and some kind of a push or pull. So a force is a push or pull upon an object resulting from the object's interaction with another object. Whenever there is an interaction between two objects, there is a force upon each of the objects. Force cannot be seen, but we can feel or observe its effect. Force usually acts on object when in contact with them, or it can act at a distance as well. Force can make objects move faster or move slower or stop them altogether. For example, if you want to check, you can just place a meter rule on table, place a toy car alongside it and push it. Mark on the meter rule the position where the car stops. Place the car at the starting position again and push it harder this time. How far does it travel? Has the car moved further this time? Your answer will be yes. And more than that, if you push the moving car from the opposite direction, what will happen? The car will slow down and will finally stop. This shows that force can change the speed of an object, can stop the object as well. What do we mean by speed? Speed tells us how fast a thing is moving. For example, the speed of a car tells us how fast it will move in a set time. Suppose a car is traveling at a speed of 100 km per hour. It will travel a distance of 100 km in 1 hour if it stays at this speed. For example, one example I have that is related to the speed. A sports car travels at a speed of 200 km per hour. How far will it travel in 6 hours? From the speed and time, it is easy to work out how far the car will travel. We say that distance traveled is equals to speed multiplied by time. Here, we need to find the distance, so we know that if you can write as a symbol that d is equals to s multiplied by t. S given as 200 km per hour and t is given as 6 hours. So just putting the values, now we just do the simple multiplication, got an answer, d is equals to 1200 km. That is the distance traveled by a sports car in 200 kilometers speed and in 6 hours. Learn this formula, students, and try it with the different number. It's one activity given in your book page number 86. You can put it the values and you can find out the different distance, and time. Force can change the shapes of an object. When you stretch a rubber band, what do you see? The rubber band becomes longer. This is because you are exerting force on the rubber band. You are stretching it. When you squeeze a piece of plasticine, what happens to it? The plasticine loses its shape. It compressed by the force of your hand. If you squeeze a piece of sponge, what happens? Does the shape of the sponge change? Stop squeezing the sponge. What happens? Does it change shape? Your answer will be yes. When you squeeze, it will get smaller. And again, if you are leaving, so it will come back to its original position. So from the above examples, we can see that force can change the shape of an object. Force can act on objects from a distance. Place a magnet near to some pins. You will see the pins jumps and sticks to the magnet. What causes these pins to jump? Magnetic force. Yes, you already learned in book unit number 7, magnets and magnetism. A coin falls on the ground because the force of gravity is acting on it. We can see the force can also act on objects from a distance. Machines. We use machines all the time. They are everywhere at home, at work, on the roads, in the sea, in the air. A bicycle, a car, an aeroplane are all machines. We use many machines at home: a sewing machine, a washing machine, a clock. Machines make our work easier, but they cannot work by themselves. They need some kind of force to make them move and work. So, student, here we are going to discuss about simple machines. A simple machine helps to make your work easier. It can turn the force of your hand into a form of movement that helps you to do work. Knife, scissors, spoons, inclined plane, wedges are the example of simple machine. Kinds of simple machine. One very useful kind is lever. Even for example, when a spoon is used to open the lid of a can, the spoon is acting as a simple machine called lever. If you try to open a tin can with your fingers, you will have to apply a lot of force. A spoon acting as a lever makes your work easier. Lever system in our bodies. There are many lever system in our bodies too. The elbow and ankle joints are two examples. In the elbow, the joint acts as the fulcrum, and the weight of forearm and object held by forearm act as load. The effort is applied by the two muscles in the upper arm. Forces work in pairs. Forces always work in pair. Action and reaction work in opposite directions. The principle is used in space rockets and jet planes where engines expel hot gases and the reaction pushes them in the opposite direction. Muscles also work in pairs. When one muscle contracts, the other relaxes. With the help of these muscles, we can move our hands and legs easily. Pulley. Pulley is a simple machine which is made up of wheels. The wheel of pulley turns on an axle. There is a groove around the rim of pulley which holds a rope. When the rope is pulled, the pulley lifts the heavy load. Where you can watch one video to see that how simple machines work in all around us.
Today's topic simple machines. Wow, I like this very much.
Yes, let's go to the slide.
Whee! This is so much fun.
Yes. Oh, do you see that as well?
Oh yes, people are pulling water out of that well. Let's go there.
Let's go.
Oh, what is this wheel?
Oh, that one? On which the rope is moving?
Yes.
This is called a pulley. It helps to pull out water easily.
But how?
Let me show you.
Let me pull it. This is so difficult.
Oh, now try to pull this bucket.
Oh, it is easy to pull.
You know, you could pull it because of the pulley. This is called a simple machine.
What are machines?
The instruments which make our work easier are called machines. There are machines like cars, fans, but those are complex machines. But pulley is a simple machine.
The instruments which make our work easier are called machines. Oh, can you show me more simple machines?
Yes, in this garden only. There are many simple machines. Come with me.
Oh, can you show me more simple machines?
Yes, in this garden only. There are many simple machines. Come with me. See, this is also a simple machine.
A slide is a simple machine.
Yes, see this.
Wow, they are using a slide to load the material. And it looks so easy.
Yes, this is called inclined plane also. See, this makes our work easy.
Yes, that is why slide is called a simple machine. Inclined plane.
Whoa, did you see that? How fast he went.
We are going on foot. He was on a cycle.
Yes, cycle also travels fast because of its wheels. See this tempo. So, wheels helps to travel and carry load.
So, wheels are also simple machines. Wheel!
Oh, see here what the gardener is doing.
He's trying to move a big stone with a rod.
Yes, this rod is called lever.
Oh, lever?
Yes, let me show you its different parts.
Lever? Hey, it is fixed at one point.
Yes, the fixed part is called fulcrum. And see, he's putting force with his hands. It is called effort.
What is stone called here?
Oh, it is called the load. Do you know there are many kind of levers?
Many types of lever.
Yes. See, fulcrum is on center here. And see here.
Oh, effort here is by the person.
Yes, but fulcrum is on the other side. And load is in the center.
Yes, in first one, fulcrum was on the other side. And here, it is in the center.
Let me show you one more type.
Oh, here effort is in the center.
Yes, load is on one side and fulcrum is on the other side. Let's see one more kind of lever. Now, can you tell me Where's the fulcrum on this simple machine?
Oh yes, it is the center. It is fixed.
And where the effort is put?
Effort is put from the back and load is on the front.
You know, this is also a simple machine.
Yeah, it looks like a nail.
Yeah, it is a nail with groove. Can you tell how these grooves help?
Hey, the nail can come out easily, but with grooves, it can't come out.
Can you tell any use of it?
Oh, we can hang our clothes on the screws on the walls. Screw!
Oh, there are many more uses of it. See, the screw jack.
Oh, even my papa's car has one.
See, the screw in the jack moves and it takes the car up.
Hey, I did not know a simple screw can lift a car.
Oh yes, that is why these are called simple machines. They can do big things but are very simple.
Today, I learned about pulley, inclined plane, wheel, 3 kinds of lever, and screw.
So, students, read the lesson thoroughly so you can understand more about foods and machines. Have a very nice and blessed day. Thank you, students.